Alright, this is example 3. In this example, the numerator has a higher degree than the denominator. Whenever that happens, you have to do some long division. Okay, so we're going to do that first. We're going to do some long division. So x squared minus 2x minus 8. And you might think, well, can't you use synthetic division? Well, if you know how to do synthetic division with a quadratic, go for it. It is available. It's not really any simpler. Okay, and then you might say, well, what if it's a linear? Well, if it's linear, you won't be using partial fractions. Okay, and you would still divide though. So whenever the degree of the numerator is higher than the degree of the denominator, you always divide. Okay, there's no. All right, so how do I divide this? So you just compare the first terms of each. So x squared times what gives me 2x cubed, and it's just 2x. Now you take your 2x and multiply all three parts. So 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times negative 8 is negative 16x. Change signs, or just basically subtract. So that cancels, that becomes positive x plus 5. This degree is now less than that, so that's the remainder. So it's plus x plus 5 over x squared minus 2x minus 8. So this is the first rewrite. So there's the 2x plus x plus 5 over x squared minus 2x minus 8 dx. Alright, now we're going to take this, x plus 5, over x squared minus 2x plus 8. Alright, that's what that is. Oop, it's not plus 8, it's minus 8. Alright, and then we're going to factor that. So factor the denominator, and it's going to be x minus 4. Oops, I don't need those parentheses. X plus 2, and remember a and b. Okay. Alright, so go ahead and multiply through by the common denominator. That's going to be a times, remember it's always the missing factor, x plus 2 and b times x minus 4. Alright, so left side there is no missing factor, so nothing gets multiplied with the numerator. Alright, continuing, remember you choose values for x to wipe out either a or b. I'm going to let x equal negative 2. If that happens, you plug in on the left side, you get negative 2 plus 5, which is 3. And a gets wiped, so it's b times negative 6. Right? Negative 2 minus 4 is negative 6. Divide by negative 6, and you get b equals negative half. Now let x equals 4. Right? 4 will wipe out the b. So that would be 4 plus 5 is 9. And 4 plus 2 is 6, so 6a. So a equals 3 halves. Right, 9 divided by 6 is 3 halves. Alright, so that means I'm going to take this and rewrite again. So it's 2x plus, except now I'm going to write a, which is 3 halves, over x minus 4. 3 halves over x minus 4. And b, which is negative 1 half, over x plus 2. So negative 1 half over x plus 2 dx. Let's go ahead and integrate that. Integral of 2x, right? This is normal. You know how to integrate 2x. For some reason, people get confused of how to do normal integration when we start doing complicated stuff. Just the power rule. You add 1 to the exponent, divide by the exponent. Divide by the new exponent, right? So that would be x squared over 2, but the 2's cancel. So you just have x squared plus 3 halves. Natural log of x minus 4 minus 1 half. Natural log of x plus 2 plus c. All right. Let's clean that up some. I want to take out a half. Right, so when I do that, it's going to give me natural log, and I'm going to take the 3 and make it an exponent. So it's x minus 4 to the third minus natural log of x plus 2. So I have x squared plus 1 half. Okay, I'm going to write that as 1. So it's natural log of x minus 4 to the third over x plus 2. I guess I don't need this parenthesis. Alright, plus c. Alright, sorry if that looks really messy. I don't want to put square root on that just because. Alright, so that's it. Chances are good that the answer form you'll be looking for will be the first one. Okay, but you need to be prepared to be able to move things around using your properties of logarithms. Alright, that's it.